Hello, chemistry, and welcome to my island. It is Mole Island, where everything is beautiful and tropical, and you can go anywhere. You can go to Liter Island and Graham Island, and you can also go to Adams Island. No matter which island you want to go to, there's only one rule to traveling to my island. You can only go to Mo Island and then back out again. You cannot go around from Graham Island to Adams Island. That is no. That is big, big no. There are sharks. Sharks, I tell you, that will eat you on your little boat. You cannot go that way. You cannot go from Adams Island to Graham Island. That is a no. There's a skull, crossbones. You cannot do that. That is death. That is death. Liter Island to Graham Island is no. No, I tell you. No. You can only go to and from my island. That is what makes my island so special. Apparently, there's also Italians on my island. Okay, what are we talking about here? We are talking about one-step mole conversion. What is a mole? Well, you now know that it is a count. 1 mole is equal to 6.02 times 10 to the 23rd atoms. It's also equal to grams, which is the molar mass. And that number we get off the periodic table. All right? So 1 mole of anything is equal to its atomic mass in grams on the periodic table. So we're going to do one-step mole conversions, which is just on and off my mole island. Anytime you see grams, that should tell you one very important thing. Molar mass. Molar mass is the sum of all the grams in the formula. The sum of all the masses in the formula in grams. For example, oxygen's atomic mass is 16 and hydrogen's atomic mass is 1.01. And if you look on our formula right there, there are 2 hydrogens, so that's times 2. Gives us 2.02. So the molar mass of water is 16, 17, 18 is 18.02 grams per mole. Okay, the question says how many grams are there in 3.5 moles of water? Okay, so I'm on Mole Island at 3.5 moles of water, and I want to go to Graham Island. I'm going to set up my unit conversions. And 1 mole of water is 18.02 grams of water. You can cancel out a unit on the bottom for the unit on top. And so then I just multiply across. 3.5 times 18.02 is 63.07 grams of water. So in 3.5 moles of water, I have 63.7 grams of water. All right, it's going the other way. We're on Graham Island, and we want to go to Mole Island. So there are 4.5 grams of hydrochloric acid, and I want to know moles. All right, I'm going to need molar mass. When in doubt, go to Mole Island. Chlorine weighs 35.45 on the periodic table, and hydrogen weighs 1.01. So that means my molar mass of hydrochloric acid is 36.46 grams in 1 mole of hydrochloric acid. Okay, so I can get rid of a unit on top for a unit on bottom, and I'm left with that. So I'm going to multiply all the way across, which is 4.5, and then all the way across the bottom. Technically this is over 1, right? Which is 36.46. And I'm going to divide out those two numbers, and I get 1. Oops, I'm screwing this all up. I get okay. I'm sorry. All right, we get 1.23 moles of hydrochloric acid. Okay, so what else is a mole equal to? Well, not only is it equal to grams, but 1 mole is also equal to 22.4 liters. We usually refer to liters of a gas, but you're learning, so we're also going to use that in terms of liquid too. And I also usually, to notate liters, I do a capital L. Okie doke. So if one, that's my daughter, if 1 mole is equal to 22.4 liters, then how many liters are in 2.4 moles of sodium chloride? So I always start with what I'm given, 2.4 moles of sodium chloride. And I want to cancel out this unit, so 1 mole goes on the bottom of sodium chloride, and 22.4 goes on the top. Since these are both over 1, I just multiply all the way across the top. 2.4 times 22.4 gives me 53.76 liters of sodium chloride. Alright, now I am on liter island and I want to go to mole island. So if I have 29.5 liters of H2, hydrogen gas, and I want to go to mole island, my unit for liters is going to go on the bottom, and 1 mole, my placeholder essentially, goes on top. And cancel out a unit on the bottom for a unit on top. I'm left with moles. So 29.5 times 1 is 29.5 divided by 22.4 gives me 1.31 moles of hydrogen gas. Is a mole equal to anything else? Well, yes, 1 mole is also equal to 6.02 times 10 to the 23rd, Avogadro's number. This is also referred to as atoms, or FU, formula units. You'll also see it as molecules, particles. When I write it out on the board, I usually just use atoms because it's a little shorter. Now, in using this conversion, you're going to have to use scientific notation on your calculator. Alright, so I want to go atoms, and I have 0.74 moles. So I'm on mole island, 0.74 moles of carbon dioxide, and I want to go to atoms island. Well, 1 mole of anything is equal to 6.02 times 10 to the 23rd atoms, right? And I can 1 mole on top, 1 mole on bottom, and I just multiply all the way across. And this is where you're going to have to use your calculator to do this part. And I get 4.45 times 10 to the 23rd atoms of carbon dioxide. Okay, and the last one here is how many moles. So we're going to mole island, and it gave us molecules. I have 8.3 times 10 to the 19th atoms, there are 6.02 times 10 to the 23rd atoms in 1 mole of this potassium aluminum sulfate. But that's in anything, right? All right, so now you're going to have to divide in scientific notation, and that's going to give us 0.000138 moles of this potassium aluminum sulfate. All right, now that brings me to a point. On your test, you may not see a whole number like this. I might say, give me your answer in 2 significant figures. Well, the only way to demonstrate this into 2 significant figures is to put it in scientific notation. And all of your answer choices, A, B, C, D, could also be in scientific notation. So, I'm going to put this in scientific notation. 1, 2, 3, 4. 1.38 times 10 to the minus 4 moles. And if I wanted that in the form of 2 significant figures, I would just round that number out. So 1.4 times 10 to the minus 4 moles of KAlSO4. And this would be your complete answer. All right. And that completes our tour of Mole Island.